Hi everyone, my name's Tim Kington and this is Coding is for the Birds. Daisy says hello as well. We're working our way through building a Java virtual machine, and today we're going to get to the point where we actually execute some code. So we have a very simple program that's assigning x the value of 1, and I'm not going to give up until that code is executing. All right, today I'd like to get to the point where we can run some code. We do still have some refactoring that needs to be done, but I think I'm going to ignore that for the moment. We do still have some refactoring that needs to be done, but I think I'm going to ignore that for the moment. The parser class right now builds up a list of constants and method objects for a single class file. So this design won't work once we have more than one. But let's ignore that problem. We'll just go ahead and assume there's a method with the right name, and we'll pull that out in our main, and then we'll try to execute that. So we have a couple of methods right now. Yeah, we've got a method main. So for now, I think I'm just going to cheat and look for the method main, and then we'll try to execute that method. So we have a method object, and it holds a list of attributes in it. I think we want to change these attribute lists to be maps. So let's update this. Make this a map from string to attributes so that we can find the ones that we're after. Oh, it looks like we weren't using that attribute list anyway. I'm going to need to do a put here. And I guess our attribute interface is going to have to support the name. So do that, and then we'll put get name matter. And this should be attributes, I guess. We don't have get name right now. We need to add that to the attribute interface. Public does it. I guess we should make this a base class. We'll have a name, constructor, and then we'll fix our attribute classes. So this one, that. Okay, so that's decent. Our method now has a map. We'll be able to look up the attribute we care about, which is code. So let's go to MyVM and do that. We also want to store the methods that way, right? The methods really should be in a map. I guess we can't just store them by name. To do this right, we need to do more work than I'm willing to do right now. We need to handle overloading. We need to handle which class they're in. So I'm just not going to do that yet. We will find the one we want by name. So method name, method. Not equal. did not explode. So we found the code attribute. Now inside our code attribute, okay, so the byte array code is our code. Now we need an execution engine. So let's create, I guess, a new package for that. This is probably going to get pretty complicated as we go along. For now, we have engine.java, and we'll have just an execute method maybe. And we'll give it a byte array with some code in it. Or maybe this probably should take a code attribute. Okay, and then we're going to have a program counter that starts at 0. And we'll say while PC is less than code.length. We keep running. Not code.length, but code. Yeah, it's called code.code, isn't it? So maybe we'll call this opcodes. We'll get an opcode. So code.code sub PC. And if we hit the default case, then we're going to throw an exception. An opcode. I guess we can. And this is going to happen right now. Let's create a new engine. And we'll say engine.execute the code. We'll find out what our first opcode is. Okay, it's 4. Let's go find out what 4 is. So there are a huge number of opcodes in here. Unfortunately, they don't have a table that's nicely organized by the value that I want. Oh, they just showed as 0x4. Okay, so this is going to push a constant onto our stack, and they just have predefined values, I guess. So this handles, weird. This handles -1 and 0 through 5. I guess because those are just so commonly used. So we can add a case for 2. I guess maybe we're going to need some if statements here. So 2 is -1 and 8 is the highest. So here we'll have a special if statement for that range, I guess. If opcode greater than or equal to 2 and opcode is less than or equal to 8. And this is push a constant, right? And what was the opcode called? It's a iconst. And we'll say value is opcode -3. Right, because 2 should be -1, 8 should be 5. Okay, so that should work. And then we're going to push it on the stack. So we'll say stack.push val. That's what this does. Now our engine is going to need a stack. The stack can hold different types, but for now I think we're going to say that we can only handle integers. So let's have a stack of integer. And this will be an else case now to hit the switch. We're going to have to decide how we want to organize this code, because this file, if we put all the code in here, it's going to get to be truly hideous. Okay, so we got stuck in an infinite loop. I forgot to increment our program counter. So I guess for now we'll do that here. Okay, now we're on unknown opcode 60. So let's see what, that's OX 3C, I think. Yeah. So this is iStore 1. So now we also have some special iStore opcodes that store into local variables 0 through 3. Okay, so 3B to 3E. We're probably going to want to break this out into a phase where we kind of parse this into objects. Maybe we'll use a command pattern, and then when we execute the code, we'll use those objects. That'll be nicer. But for now, this is fine. So that was called an iLocal, is that what that was? iStore. And it goes 0 to 3, right? Okay. So we'll say var index is opcode minus 3b, and then we're going to say local vars sub var index equals stack dot pop. So now we need local variables. This is an array event, right? For now. For now, this is an array event. And it needs to be initialized. I think our code had the length for it. So max locals. All right, so we create local vars. We start running. We're going to store value. I think we might be running our code and completing at this point. Nope. -79, that's not great. This should be, what was it, integer dot to hex string? Yeah. We want to see this in hex, it'll be a lot nicer. Yeah. B1, okay. Ah, that's a return. Return void, okay. So we're at the end of our main method. So we'll add a case here. And this is a return. Why doesn't it like this? Cannot convert from int to byte. Ugh. That's ugly. I couldn't remember the syntax for a byte literal in Java, and that's because there are none. We have to do it this way. That's kind of terrible. Okay, so this is a return void. And we're going to worry about function calls and some kind of call stack later. When we hit a return void, this will get us out of the loop. I guess if we have to return at the end of a method that has a void, we don't really need the check for PC being in bounds. So when we see this, this is going to break us out of our loop. I guess we have a break already. We'll say break outer. And I think when we break, I'm going to dump our local variables. So we'll say, we're going to do an arrays.toString of local vars. Run it. Amazing. So we see 0 and 1. Our first local is args, which is really a string array, but we're not handling that. And we're not using it, so it didn't cause a problem. And then x got the value of 1. So we managed to run a very simple program. Let's make this slightly more interesting. And we'll add some other variables. Y is 2, z equals x plus y. Let's try that. This would have been optimized away if I just said something like x equals 1 plus 2. So I'm going to do it this way because we want to be able to actually have an add operand in our code. And if I go ahead and run my project now, we'll probably get it blowing up on an add instruction, I would expect. So 1b is probably going to be some kind of add. No, it's a load from a local. Okay, so we have I load 0 to 3, start with 1a through 1d. This is an I load, and we'll say our index is outcode minus a, and then we're going to do a stack.push whatever's in the local variables at that index. Now we'll probably break on an add instruction. 60 hex. I add, there you go, add ints. So this is going to assume that value 1 and 2 are on top of our stack, and then we put the result back on the stack. I guess we'll say I guess these should really be reversed because the stack has already reversed our operands. Let's try that. Okay, so now we have 4 variables and they have the right values, but this is a very fishy output, 0, 1, 2, 3. That seems like it could happen by accident. So let's change these some. We'll make this 3 and 1, and then z should be 4. And I have to run this to get it to compile. Okay, so we see 3 for x, 1 for y, and 4 for z. So we are actually running some code now. All right, well, we have some simple code executing now. It's very simple. We probably could not execute the code if we used a constant larger than 5 right now. But the basics are in place. We've got a stack, we've got an array of local variables, and we've got the main loop that's going to work its way through the code and execute the instructions. So from here, we'll keep adding features. Thanks for watching. Don't forget to like and subscribe.